Okay, now let's look at these ideas to examine what the graph of the inverse sine function needs to look like. So here I have a sinusoid. If you think about this for a second, if I asked you whether this was sine, cosine, or tangent, you'd be able to figure out that this was sine, because this function evaluates to 0 when x equals 0. It reaches its maximum here. This on the x-axis I just have integers, but this is the value of pi over 2. It comes back down to 0 here. It looks like 3.1. This is pi. So this here is the graph of y equals sine of x. So if I want to talk about the inverse graph, we know that we can take that and reflect it across the line y equals x. However, we can only do that to find an inverse function if the original function is 1-to-1. This function is definitely not 1-to-1. It fails the horizontal line test very badly. If I draw a horizontal line here, it's going to intersect that in infinitely many locations. So we have to restrict the domain. So look at this for a second and think, well, how can I restrict the x domain such that I have exactly that I never fail the horizontal line test? If you think about it for a second, you'll realize that you need to take one section of the graph like this. So if you take it from the trough to the peak, then you have something that's 1-to-1. I would note that this is not the only choice we could have made. For instance, if I had restricted the graph from here to here, I would also get something that is 1-to-1. If you do that, that is a non-standard choice for the domain that will lead to a different different choice for what the inverse sine function is. So, there's more than one way to do it, but this is how we do it. So let's see exactly what these values are. This here is minus pi over 2, and this here is pi over 2. And this is between -1 and 1 on the y-axis. So if we do that same thing, draw our line y equals x, like so. And then think of reflecting all of these points across. This point here is going to end up right here. This point here is going to end up right here. And so I'm going to get a curve that looks like this. And similarly, this point here is going to end up here. This point here is going to end up here, and I get a curve that looks like this. All right, so I have prepared this graph of inverse sine on a separate sheet, and so I'm gonna put that here. So this here is the graph of y equals inverse sine of x. All right, so next we need to talk about the domain and range of the inverse sine. So the domain is a set of all values that this function can take. And if you look at this clearly, this is between -1 and +1 on the x-axis. So I would say the domain of sine inverse of x is the set from -1 to 1. I'm using square brackets here because these are included. We can compute the inverse sine of -1 and the inverse sine of 1. And the range of inverse sine is the set of all y values. So this is coming from here to here. On this axis, it looks like it's from about -1.5 to 1.5. But of course, you realize soon that these are exactly minus pi over 2 and pi over 2. And again, these are included. So this is the domain and range of inverse sine.